All right, greetings, Saintsman. We are completing lesson 10.4, which is regarding inscribed angles and polygons. Let me get the drawing auto shape feature on. Make sure that you have your compass. I will be checking in class when we get back there. Make sure that you guys are bringing it. If you guys recall, we had central angles that we were drawing, right? And for example, this is ABC. And angle ABC is a central angle because it's drawn for the center, where you have the measure of angle ABC is equal to the measure of arc AC. All right. Now, if I do the following, and we're going to have now an inscribed angle. So rather than forming the angle at the center, all right, I'm now going to form this guy inscribed. So I have A, B, C. And the measure of angle ABC is going to be equal to half of the arc of AC. All right. And ABC is what we refer to as an inscribed angle. An inscribed angle, half the measure of the intercepting arc. Okay. Also, an inscribed angle is formed on the circle. The vertex on the circle autocorrect is killing me. Okay, I can't. By 2 chords. Okay, so this is food for thought here. You guys see this? Where, let's say I'm going to take a different point here. I'm going to take this point, and I'm going to call this B prime. So this is just another version of B. Because if I connect these guys, what you guys can see is that because these share the same intercepting arc, oh my goodness, that was crazy. Do that. Because they share the same intercepting arc, AC, angle ABC is going to be equal to angle B prime C. They have to be because they share the same intercepting arc AC. Okay, so let's have some fun here. Let's do a diagram. Big diagram, big circle. Okay, and this is going to be circle F. Turn off the auto shapes thing because it's going to cause more problems. Okay. On this, I've got A, B, and I'm going to create a chord here. I'm going to create, let's see here, one here. Oops. Just going to connect to that point. One here. Okay. And one down here. Let's go up to this guy and this guy. This is B, C, D, E. This is circle F. It's G. I think I got all my parts. Okay. So I've got 2. Okay. Oh, I got one more line. It connects chord GE. Oops. All right. So I've got angle 1, 2. This is 3, 4. This is 5. Okay. So what I have here is given. I have circle F. All right. And this is one of those where I'm going to get these questions in kids in class who are just going to start the problem sets and say, how did you get this? How are we doing this? And the answer to that is, this is how it's when we actually do these examples together, if you follow along, because I'll take you through the problem solving process as I solve this. The measure of arc AB, this is all given, is going to be 20. The measure of arc BC is going to be 40. The measure of arc GD is going to be given as 108. And I know AB and BC look similar, but they're for sure different. And the measure of AG is the same as CD. Oops. All right. Now we're going to solve for each of these numbered angles. Okay. Angle 1, angle 2, angle 3, 4, and angle 5. What are these all equal to, given what do we have here? Now, let's take angle 1. Now, angle 1 opens up to arc AG. Okay. Do we know what AG is? Well, we know it's the same as CD, and we've got to find what CD is. Okay. So, the issue then is, what is that angle measure? Okay. Now, BC, we know BC is going to be 40. Okay. And BC opens up to angle 2, right? Over here. So that means this guy, number 2, is going to be 20, right? Because it's going to be 1/2 of BC. Angle 3 opens up to GD. Well, GD we have as 108, right? Angle 3 here is GBD, which is this arc right here. So half of that would be 54, okay? Now we're still trying to find a solution for angle 1, all right? So we know that AG and CD are the same, okay? Ooh, you know what? I wrote down something wrong here. It was the very beginning. It was on the givens. Um, this should be AG. AG should be 20, okay? My apologies. So let's rewrite that. This guy's going to be 20. And angle 1 is 10. Angle 4, we have to find out. We know angle 3. We know angle 2. And this is going to be the interior angle sum because we have here a triangle right there, right? So angle 2 plus angle 3 plus angle 4 will equal 180. Okay, so we back those other guys out. It's going to be 74. Subtract them from 180, and that's going to give us 106. And then 5 is going to be, again, GD, which we already were given, right? For angle 3. Same deal. Opens up the same corresponding arc. So angles 3 and 5 wind up being the same. All right? So let's go with a few properties here. The inscribed angles of congruent arcs are congruent. Okay? That's through, we can see that exemplified in angles 3 and 5. All angles inscribed to the same arc are congruent. All right? If inscribed angles intercept a semicircle, well, think about that. A semicircle has a degree measure of 180. So if the intercepting arc is always 1/2, then it's going to form a 90-degree angle, which means it is a right angle. Okay. So another problem here. Do another example. All right. I gotta draw these chords here. Struggling. I see there's a little chord right here. for circle P. And these guys are V, U, S, and at the bottom we've got T. Okay. So for our givens, I'm going to have angle 2 right here. This is going to be angle 1. And our givens are this, that this is circle P. And SU is equal to UV. Okay? Moreover, angle 1 is equal to x plus 9, and angle 2 is equal to 2x plus 6. So our problem is that we're going to find the measure of angles UTS and measure of angle VUT. Okay? So, how do we do this one? All right? Well, let's start to mark the things that are congruent. VU and US are marked congruent. These guys right here, congruent angles, right? These are both right angles because they open up to the semicircle, okay? So they have to be, right? So UST, right, opens up to that semicircle as says UVT, okay? So what I have here is I have congruent triangles because reflexively UT, the hypotenuse, is congruent. It's not angle side or ASS, right? Instead, that is going to be the hypotenuse leg theorem. So what we know then is that this angle and this angle are congruent as well as this guy and this guy. Moreover, since they're congruent, angle 1 plus angle 2 has to be equal to 90. They're going to have to be complementary, okay? Because these are going to be corresponding parts that are going to be congruent, okay? As they are also the acute angles of a right triangle. So I can actually substitute here x plus 9 for angle 1 plus 2x plus 6. That's equal to 90. So we have 3x plus 15 equals 90. Subtract 15 from both sides. 3x equal to 75, so x is equal to 25. Now, we want to find UTS, right? UTS is the same as angle 1. We found out that those guys are congruent. So we're going to, angle 1, we're going to plug in 25 plus 9, which is equal to 34, which is equal to the measure of angle UTS. Angle 2 is going to be complementary, right? So that's just going to be 56, right? 90 minus 34, right? To give us that guy right there, okay? Which is going to be the measure of angle VUT. Gentlemen, I'm showing you the minimum of what I need to see when you guys are working, okay? Couple more examples here for you, okay? These guys will be quick. Here they are. 1. This is an example of what is called an inscribed polygon, okay? We're going to inscribe it into the figure, into the circle, right? Versus if we have a circumscribed, what we have here is that, first comes this guy, this triangle, and then we're going to create the circle around it, okay? Uh-oh. You guys get the idea. I'm actually going to... There. Ah, gosh. I can recenter that a little bit better here. There it is. Okay. And this is circumscribed. Circumscribed circle. All right. So, fun fact. An inscribed quadrilateral will have opposite angles supplementary. Okay, this is just a theorem, and I'm can prove it with you guys in class, but it's one of those the juice really isn't worth the squeeze. So here's going to be the problem. We're going to take quadrilateral QRST. Oh no, that auto shape thing working again. And it's inscribed into circle M. So if the measure of angle Q is equal to 87 and the measure of angle R is equal to 102, we're going to find the measure of angle S and angle T. And here's how we do it, okay? It has to do with this. Q and S are supplementary, right? So I can do 180, because that's what this guy says, they're opposite. So 180 minus 87 to get angle S, which is going to be 103. Okay, and then for angle T, it winds up being 78, right? Because again, it's going to be 180 minus 102, right? Because of those guys, every other letter, those guys are going to be opposite angles from each other. And that's what I got for you, Saintsman. So good luck. I'm going to post this onto Canvas and give some guidance there too.